Hi everyone, I'm JK, and how are you today? Have you enjoyed NDC? Thanks for coming for the last session, and thank you for having me here. This is my first NDC talk so far, and yeah, let's go. So I'm talking about Microsoft face recognition with real-time face recognition with Microsoft Cognitive Services. And I am Jernej Kavka, but I know how hard it is to pronounce, so you can just call me JK. You can follow me on Twitter, GitHub, blog posts, and LinkedIn. You can also snag the Twitter QR code. And by day, I am a .NET Core and EF Core developer, and at night, I am basically a ML.NET and cognitive service developer. So let's get into it. So this talk is going to be focused on the real experience that we had developing real-time facial recognition on cognitive services. We're not going to see too much code. We're going to focus more what were our challenges and how we overcame that. And we'll start with a test study, test case that is now in production. You could have seen it at SSW booth, our SSW Sophie hub. And at the end, we're going to look a little bit aspirational, looking what you can do further with cognitive services with things like infrared and depth cameras. So let's get into it. So let's look what our SSW Sophie hub is, so we understand the challenges we had. So that was our smart office solution, where when some users come into our office, we showed them relevant content. So for instance, our boss, Adam, came to the office. He was greeted by a Sophie system. He got his appointments, and then he could get the instructions where to go. Simple, isn't it? And it's mostly powered by cognitive services when it comes to who is in front of the display. And why did we choose cognitive services? We could choose a lot of other different solutions, but one major thing that I found with cognitive services is easy to implement. So I basically take one weekend, a little bit work, 1 hour, and boom, first prototype done. It's like, yeah, we can do it. And, you know, that's where we got to today. And one very important thing that was for us was we have offices in Sydney, Melbourne, Brisbane, and in China, and having one unified database is very, very important for us. And the Azure Cognitive Services gives us that. And when you think about cognitive services and cloud, you would think, okay, we need to send images up there and stuff like that. It shouldn't be fast, right? But for some reason, it is fast. It's almost as fast as some of the offline solutions that you can use, which is very amazing. It's also available everywhere. As long as you can do an HTTP request, you can do that. So for instance, here I have a Raspberry Pi Zero with a camera. So you could just put the application on this, plug in power source, and boom, you have a Sophie Hub camera in this little device. And what is very important for us as well is Microsoft is constantly improving the service. So just recently, we are working together with a South African company, and they're trying to use this for security reasons, where people are not supposed to be, and they're just trying to figure out, is that person supposed to be in that place? Now, Microsoft is trying their very best to basically cover everyone. It doesn't matter what skin tone you have, it doesn't matter what gender you have, it doesn't matter. If you're not being recognized, they want to be accountable. They want to know about it, and they want to fix it. And they're one of the few companies, they basically tell everyone, hey, make us accountable for what we do. And this gives us confidence that when somebody approaches us and, hey, we want to deploy to X country, that we can say, yeah, I think we can do it. So this is why we chose cognitive services. It offloads a lot of problems we have currently with facial recognition to Microsoft. But what were the challenges when we were trying to use them? So one of the major challenges that I was a bit surprised at the beginning was it can cost a lot. And major reason for it was, do you know how everyone did the demos where you just press the button or upload a file and then you did recognition? Even when you had that automated door openers, you had to press a button. That was by design because it's actually quite expensive if you do this 24 hours. But that doesn't mean it has to be expensive. And what we also wanted to do is one of major goals of SSW Sophie Hub isn't just to recognize a person. It's also show them the relevant content and also know, okay, that person left. Maybe a different content has to be shown or a new person came into the view. So we need to adapt to what's going on. And another challenge we had, a very interesting one, is cameras and the quality of images. So you really, really want a good quality image, and we'll get to that later. So first challenge we had was pricing. And to understand why this is a problem, like with all Azure services, all AWS services, everything that is pay per usage, you have to understand why does it cost a lot. And if you remember anything from this talk, is to try to understand why something costs a lot. So first tier, free tier, it has maximum 20,000 transactions per minute and 30,000 transactions per month. So what does that mean is if you're doing a simple example, like you're trying to identify lots of people on your Facebook or things like that, it may actually fit your bill. You might be able to use your free tier and not pay a cent. 30,000 transactions is actually a lot. However, we're talking about real-time facial recognition, so the number of transactions is going to be a bit higher. So that's why we have to look at the standard tier. So here we have 10 transactions per second, and we have 1,000 transactions for $1, which is 1.373 Australian dollars for the last 1 year. Checked today, it's still the same cost. But you know what? In December 2017, it was 1.8 US dollars, so it was like 2 point something Australian dollars. So it's getting cheaper. So this problem is going to be less and less of a problem, but it's still something you want to consider no matter what kind of service you're dealing with. And if you're interested in the cost, you can check out this URL. But let's move on. So I said that real-time facial recognition can be expensive, but why? Well, let's have a look at a naive implementation. And let's say we recognize one face every 5 seconds for 24 hours, a fair assumption. And then we say, okay, we have no cache, we have no external database, and that will cost us $70 per day. Okay, so how did I go to that number? Well, one good thing before going to do that, it used to be $130. So we basically save half of it just by waiting. That's it. But why does it cost so much? Well, let's look how do we consume transactions. So first, for one person, when we're trying to detect a person, when we try to recognize a person, we first need to detect them. We need to detect their face, which gives us back a face ID. Then that face ID has to go into identify, which then gives us back a user ID. And then we can feed that user ID into get person, and then we get user data. And that, in total, is 3 transactions. Each step costs us 1 transaction. Now, when we expand that to 3 people, what happens is, well, we make 1 API call for all 3 people, and we can actually detect up to 64 faces for 1 image for 1 transaction. So that's fine. When we identify those faces, we pay only 1 transaction, only 1 API call, up to 10 faces. So that's good. Still pay 1 transaction for all 3 faces. Now, if you do a naive implementation, you will pay 3 transactions because you will have to get the user data for each individual person. So you end up with 5 transactions. But, you know, that sounds really small. Like, if you have, if anyone went to William's talk about Azure Cosmos and SpendOps, he showed a tweet where it's like, oh yeah, this 1 RU, 1 unit is like super, super cheap. And here's a similar situation. But when you do stupid things, you get a huge bill. So let's see why are we getting a huge bill. Before, if anyone knows about streaming APIs, Vision API has streaming and offline support. Face API doesn't. So let's see how I calculated with all that knowledge our cost. So first, we go with one assumption that we detect 1 face every 5 seconds for 24 hours. That is 36 transactions per minute. Well, it turns out there's a lot of minutes in an hour, in a day. So we have 52,000 transactions per day. So free-tier only have 30,000 transactions. So you cannot even have a full day under those conditions on a free tier. And if you go with with assumption that you do without any recognized faces, you still get 17,000 transactions. And that's still $24, doing nothing. So how can you fix that? Well, you can reduce costs very simply by doing a couple of things. So first, you cache users. Now, I figured out a bit late that you can actually get all of the users of a group, just list all of the users, and you get all the data. You don't have to go one by one. So you basically save a lot of transactions. Well, to be exact, 33% of all transactions just by caching all the users. And the other one, it might be surprising, including offline face detection libraries. Now, okay, we're using cognitive services to do facial recognition. Why are we now including some offline libraries? Well, you know, what you really want to do is reduce the number of transactions you're sending to cognitive services. And why do you want to tell why do you want cognitive services to tell you, hey, there's no face, I can't do anything? Wouldn't it be better that you try to figure out, okay, there's a face on my side, cognitive service, please recognize that. That's the hardest part, is to recognize faces. Detecting faces just means, oh, there's a face. I have no idea about that face. But recognizing is the hardest thing in this whole workflow, and we still let cognitive services deal with that. And if you think about, okay, wouldn't it be really hard to implement those offline face detection libraries? Well, in C# you have UWP APIs. In fact, if you run the Windows camera, you will actually see the blue rectangle. That's actually face recognition, face detection that you can use in your UWP application. In fact, the Sophie Hub is using UWP in order to detect faces offline. But if you don't want to use UWP, you have OpenCV for C#. If you're doing in JavaScript, you have TensorFlow. And you have BRFV4, which is a really interesting name, but what it allows you to do is not only detect faces, but also do real-time emotion detection. So if you want, even though cognitive services gives you all of that, if you need to have that in real time, it can be very useful. And if you're doing Android, RS, Python, all of that is available in the native libraries. So offline face detection is actually not that hard to implement nowadays. But when we go a little bit further ahead, so this is going to save you like massive amount, like about 90% of the cost. But when we go different challenges, like when you try to not just identify there's a face on the picture, if you want to also know whether the person is still at the Sophie Hub, and you want to improve your UX based on whether the user's there or a new person comes in, you need to track their faces. And also, there's another interesting thing. We found some unexpected spike in cost because we weren't doing something wrong, right. And to explain it this best, this is when we implemented just detecting faces and sending the pictures, the cognitive services, only when we detect the face. And we were like, yeah, everything seems to be looking good. Until on Friday, I see a spike. And I was like, whoa, what's going on? Why do we have a sudden spike? Can somebody guess what happened in reception that could cause such a spike? Excuse me? We didn't have a party, but what happened is we added an ad. And, you know, Adam Stevenson, I think he's worth it. But I think I would prefer that that cost goes to something else, not to the Face API. I want my services to be very cost effective. So what happened is the face is there all the time. So what we need to do is we need to figure out whether we have any moving faces. So what I'm doing is I'm trying to track the faces. So the offline libraries give you a rectangle or a circle where a face is, and what you only have to do is just calculating deltas between previous and the current frame to figure out whether the face is moving or not. But I was thinking about, okay, I've shown the code in previous demos, and it was interesting to see, but what I realized is, hang on, I actually got the same result if I just track the number of faces. There's only a couple of edge cases where that is actually necessary. And what you actually just do is when somebody comes in, you have one more face, and that's where you send a request to cognitive services. And when somebody leaves, the number of faces changes. Now, the difference is this. Here, we have the previous state where we have number of faces. We get the number of faces over here in the previous state. We get number of faces in the current state. And if it's different, we send true. And if it's true, we send it to cognitive services. Now, this is only 3 lines of code. The one that detects moving is 20 lines code. So sometimes, if you don't overthink your problem, you can solve the problems much more efficiently. And once we've done that, this is roughly the number of transactions we have right now in Brisbane for the entire week. And this roughly translates about $1 a week in Brisbane office. So we went from $70 per day to less than $1 per week. Now, is it expensive? It depends how well you're thinking about the problem. But you know, what can go wrong will go wrong. So that actually happened, funnily enough, right after I finished my client work. And sysadmin came to me and said, hey, the cost is a little bit high. I was like, okay, it's supposed to be $30 for all of the offices together, not this much. And he asked me, hey, can you fix this? I was like, yeah, sure. patched it. And it really took me 5 minutes. But why did it take me just 5 minutes? Well, what happened is we got a new PA a few months ago. And both PAs were in reception area. And we have an exclusion zone. And Penny moved a little bit closer to the door. And the fix was to just move the exclusion zone a little bit to the left. That's how sometimes you can save $100 per month. Not too proud about it, but you know, if you're too long at client work and nobody pings you saying, hey, there's something wrong with the Face API, things like that can happen. And this is something where William was talking about spend ops, where you continuously track your expenses. So once something like that happens, you're being notified immediately. And when you have a resource like Face API or any cognitive services databases, you do have to keep look at your resources. So additional tips I can give you about cognitive services, specifically Face API, is before you send your images, do crop them. Because original image is going to be 150K or something like that on webcams. On Kinect, it's going to be even larger. And while Face API is going to handle that just fine, it's the problem, the upload to Face API is going to take a while. So if you crop the image and keep all the details, everything the same, you'll get a 15K image, and that is going to transfer much, much faster. It's like 10 times smaller, so in theory it should go to cognitive service 10 times faster. Another one is you can detect up to 64 faces in one image. Make a collage. So just gather all the images, like I collected everyone, well, a couple of people from the NDC page and send that instead. You'll save lots of money just doing that. Now, once you have all the face IDs, you can detect up to 10 faces. Now, in case you have a situation like here, where you have 20 faces, well, you just send 2 requests to the Face API. But instead of paying for 20 transactions, now you pay only 2. You save 10 times more than before. And also, if you're worried about, hey, can I take different face IDs from different images? Yes, you can. The identify method doesn't care from where the face ID is coming from. And what I had mentioned before is try never to fetch each individual user. Just get the entire group. You can grab up to 1,000 identities for a face group. So this is an output. You just get everything, all the data, just by listing all the groups. And one interesting thing that I found that very few people talking about doing real-time facial recognition is when you do near real-time in terms of human real-time, not machine real-time, it's not really that bad if you just take an additional delay for example, 100 or 200 millisecond. But what can allow you to do that is, for instance, you take a quarter of a second delay. You can collect 15 images for 60 frames per second camera, and what that gives you is some of those images might be blurred. And if that happens, if you just send that one blurred image, you'll get a negative result. It's like, yeah, I wasn't able to find anyone. But if you take 15 images, you put them into a collage, and then send them, some of them will not be blurry. So that means that you lose quarter of the second delay for collecting all of that, but you may actually save seconds because the first image that you could get when you detect a face could be blurry. So you're basically sacrificing a little bit of delay in order to ensure higher chance of a more real-time interaction. And one very important thing that I also learned is have a good camera. Like we use the Kinect V2 because it's an amazing camera. And I'm hoping we'll get soon the Azure Kinect camera, so we can do a lot more things, which I'm going to mention at the end. But the important thing is, the better camera you'll have, the better it's going to handle low light environments. And the low light environments can cause blurriness in your image. And you should have 1080p cameras, because if you don't have, you have a situation like this. So you can see on the left, it's Kinect camera, and you can see you have some details on the eyes, you have some details on the glasses. But on the right, you have a webcam, and these details are starting to get lost, which means that, well, these two images might still work, the right one might still work. When I move a little bit too fast with webcam, the Face API is not going to be able to recognize me because we have lost too much detail in the image. So the higher the resolution, the better. And there's also to note that you should have clear frames. So when you do the testing, make sure that you take individual frames in different lighting conditions and test them, that they are actually clear. And test them in morning, afternoon. If your people have to check out at 6 p.m., test if it's actually working at 6 p.m. It doesn't help you that your system works perfectly fine if nobody's got recognized at 6 p.m. because it's too dark for the camera to recognize people. And to show you how big of a problem a low light environment can be, I'm having here a webcam where I'm moving my head left and right, and you can see that the blue rectangle is losing me. That's the face detection. But if it takes something like Kinect, oddly enough, the image is a little bit, it's much more brighter to begin with. It's exactly the same time, exactly the same conditions, but you can see that my face is being tracked at all times. I'm not losing tracking on the face. And I have a demo, I have a GitHub repo. You can have a look. I have implemented most of the tips you have seen. The one that you've seen with the red circle, you can actually install it on your machine and have a look and try it out. And I also have recently developed, if you are interested in cognitive services and you try to try out the Face API, see how it goes, basically explore the groups, do the training, you can do it. And the interesting thing about this is it's all Blazor, client-side, PWA. So if I go to Edge, you can actually press this button, and you have Blazor in as a desktop app. And what it allows you to do is, well, I'm not focusing here to talk about the specific of how to use cognitive services. You can actually go explore with this, and you can see the actual requests that are going toward the cognitive services. So if you're interested how to use them, you can just explore, see, try it in Postman. If you need more instructions, I'm trying to update over here. You have even a Postman collection, and you can try out creating groups, creating identities, doing training. Basically, I put together almost all the operations that you need for doing facial recognition in this Postman collection, and I'm going to update this application so you can try to learn Face API as well as other cognitive services. Let's go back to the slides. And there's also new Face API features coming. That's going to be Face API on Docker. Unfortunately, I don't have the private access to that feature. So what I can tell you about it is it allows you to have scenarios where if you are not allowed to send images outside your intranet, you can use the Face API containers and serve it inside your company to have all the images inside. It's not quite offline since you have to send the billing information, but it allows you to have all your customer data can be inside your organization. It doesn't have to leave your organization. And in one of the things that we're going to implement for one of the companies is they're going to have lots of venues, and it's impractical to send all of the images to the Azure Cognitive Services. They don't have good internet, and this allows us to have like a quasi-offline mode where we can have lots of venues, and each venue works independently. And the pricing at the moment is the same as the web. So you wouldn't save money per se, but it gives you more flexibility how you deploy. And if you have limitations regarding where the data is being stored, this can help you solve those problems. So now I have talked about the challenges we had and the challenges we solved. This part is a little bit more aspirational. So if, for instance, you get yourself a Azure Connect, what can you do with Azure Connect to actually expand the features of cognitive services? So one of those things that you can do is use infrared camera. And what it allows you to do is see at night. So raise your right hand if you think that the right image is done in night. What about left? Well, this one, the right one, was the right one. But what you can see here is there's almost no difference between when the lights are on and when the lights are off. And this is done with Kinect V2, and it's really amazing because what it means is if you have problems with either the sun or you have problems that the room is poorly lit, or whatever reason you have problems with light, you can use infrared cameras to solve that problem. Now, another thing that is really good is if you have a lot of millennials that go with your iPad around and trying to log in as you, it will not recognize the displays. So they cannot authenticate by using iPad. Now, you wouldn't use infrared for security, not in this particular case, but you'll be safe from millennials. And for depth sensing camera, what depth allows you to do is see the world in 3D. And what it also allows you to do is see the face, the structure of the face in 3D. And if you're interested in more security parts of facial recognition, this is what you would use. And this is something you have on your iPhones. Windows Phone used to have that a very long time ago. So if you're interested in security, have a look into that. But my very, very favorite feature is tracking skeletons. It's something I've been doing since 2009. Now wait, when was it? 2010? Kinect first 360? And it's really awesome because it's not just tracking you, it's more stable than facial tracking, because when you're moving around, you talk with a person and you are looking away from the screen. You're looking away from the camera, and the camera cannot accurately detect you anymore. And with skeleton tracking, if you look over here, when I go into the office, you can see up above, I have a skeleton. And you can see that it still tracks me, even though I'm looking away from the camera. I'm looking away into the reception, and even when I turn around, I'm still being tracked. So how is this useful when you combine it with cognitive services? So when you come in, your skeleton is being detected with your face. That means that you know where the face is. You can then do facial recognition on that person, and once you have the identity, you can pin that identity to that skeleton. And now, when the person looks away and looks back to the screen, you no longer have to recognize them because you already know, this is the skeleton I've recognized before. I know it's that person. And what does it mean if you want to use infrared and depth streams to cognitive services? Say you want to use infrared to recognize faces. So one little caveat you have to think about is that both streams are in 16-bit grayscale frames. Well, cognitive services, at least the last time I checked, only supports 8-bit grayscales. That means you have to downscale from 65,000 to 255 per pixel. Now, if you just look at PNG and you have 24-bit image, and then you try to convert it into an 8-bit GIF, or actually 255 color GIF, you'll see there's a massive difference. The image becomes all of a sudden really, really bad. And in case of here, what's happening, you are losing a lot of fidelity. It's like you lose detail. That image should have been appeared a little bit sooner. So you can see here on the left, we have Kinect that has a great tone mapping algorithm. And you can see I'm visible very clearly. But over here, we have a similar depth sensing infrared image. But the difference is this one is not being tone skinned, which means that while it has similar amount of details, it doesn't actually translate in such a way that when you convert it into 8-bit, that you gain the same fidelity for contrast, which then makes it harder for facial recognition to recognize faces because facial recognition works based on contrast. And here you can have, if you're interested into that, you have map to HDR to LID. It's a topic on its own, like probably 1 hour. But if you're interested into doing that, you have options. And another thing that I realized is infrared images are not just color images converted into grayscale. They are actually a different look into the world. Like we shine infrared light at our skin. So when an infrared camera looks at us, we literally are seen differently. So when you try to use color images, when you train with color images and use infrared images to try to recognize yourself, you'll find that it's not going to work well. And you'll have to retrain your faces for infrared and depth images. And there's also another trick. So for instance, if you buy a Intel camera with all the infrared and depth, or you use Kinect one, you will realize that they're both differently calibrated, so you'll have to actually take different photos as a training set for each hardware. Now to recap, cognitive services are easy to use and they're scalable, but if you do real-time facial recognition, you should be having some cost consideration. There are many, many ways to improve cost and performance, and if you have special cameras, they can be very, very useful. So thank you for watching, and thanks. Any questions? Yes?
The offline stuff that's still, I was sort of quite a pretty release by now. Can you share any of the information that comes, is there any way to share information from the online services with code that uses the offline services?
So the question is if you can share information between the containers. The answer is yes. So as far as I know, as far as I've seen the demos, what's happening is when you go to cognitive services, you have you can build containers and then deploy them to other machines. I haven't tried that myself, but I have seen the demos, and yeah, that scenario should be supported. Any other questions? So, what was the main purpose of building this project, and if we had any privacy concerns? So the main purpose was to give people their appointments to basically give when they come into a smart office, that they can start the day better by already having information to jumpstart the day. And facial recognition seemed to be a really good way to do so. For the privacy concern, we have mostly only the people that already agreed with us to have their faces. So we don't recognize anyone we don't have a permission for. Does that answer your question? That is correct. Yeah, it's a similar problem as CCTVs. So right now, as far as I know, Australia does not have any law that prevents you from that, as long as you have a sign that this place has been recorded, and the images, not the images, the information about the face is stored on the cognitive services for up to 24 hours, and then it's been deleted. So while we are sending the images to the cognitive services, the information that is on the cognitive services is not the actual image. It's just what they, when they go through all the algorithms, is just that information that can be used to identify is remained. Does that answer your question? Yeah, I think there was a question over there.
In your opinion, if you're an average developer, how long would it take to implement this from scratch?
So if you're talking about real-time facial recognition, then it took me 1 hour to do a prototype. If we're not looking at the cost reduction and stuff like that, it's super easy. But if you do cost reduction and stuff like that, probably a few days, just to figure out. If you don't have something like that that gives you all the tips. Yes?
So I was just wondering, what made you decide to go with Blazor?
Well, it was more like for fun. The question is, why did I decide to go for Blazor? Well, it was really just for fun. And I was like, okay, Blazor's out, .NET Core 3 is out, and why not have a crack on it? And I was a bit skeptical when I started, and then all of a sudden I built this, and I was like, hey, this works, and I forgot to say that I actually have it on my phone as well, so I can literally show people on my phone exactly the same app, and I can just start doing all the requests. And once I build up all the use cases for cognitive services, I can just go to a user group. If somebody asks, hey, do you have something cool to talk about? I can just pull out my phone, plug it on the projector and say, hey, let me talk about the cool stuff on cognitive services. Or, you go to a client and it's like, I think this can be solved with this. And then you can show them right there. And this, because I'm storing the information, and this is on local store, so everyone will get a different one. You can use even the client's credentials, the subscription key and the base URL, so you can show this with their own data. And what I'm also trying to do is implement a little bit of spend ops, so you not only understand what is happening, and you can also copy this in Postman, you can also understand how much that costs. Does that answer your question?
It does, thank you.
So I thought I saw some questions over here. Okay, if there are no questions, thank you for coming.